Okay, so you go to your RVC tools directory and make sure that you run this script. This will make sure that the robotic toolbox is properly installed on your system. In my case, the robotic toolbox for MATLAB is release 9.10. Okay, so the newer that you have, the better it is, even if it is 10 point something. But if it is older than this one, then you can try, but I'm not sure that everything we can run in there. Okay, once you do that, then you go to your where you have stored that file, and then you'll get this one. And then I'll explain each and every command step by step. Okay, so once you have opened it, then please raise your hand and please raise your hand, and I'll be able to see it from here. So Imran, first of all, you shouldn't be doing labs on mobile phone, ठीक है? अगर आपको आवाज आए या ना आए, इससे फर्क नहीं पड़ता. Secondly, when I'm giving you something in chat, then I'm not speaking afterwards unless you do that step which I have told you here. So I will only go.
सर
हाँ जी.
सर हमारे पास लैपटॉप भी ओपन है और मोबाइल भी. सर लैपटॉप पे नेट सही काम नहीं कर रहा है, मसले वाईफाई में, और मोबाइल से कनेक्ट लैपटॉप पे मैटलैब ओपन है सर.
अच्छा, ठीक है, बस MATLAB आपके पास होना चाहिए. I just want to
यस
make sure. Yeah. चाहे आप मोबाइल से हो कुछ भी रेज हैंड तो आप लैपटॉप से कर सकते हैं ना, विच मीन्स कि आपके सामने MATLAB है और कहीं भी ओपन है, उसमें आपने स्क्रिप्ट
सर लैपटॉप से कनेक्ट नहीं है ना जूम पे. सर मोबाइल के कैमरे से दिखा सकते हैं आपको.
नहीं तो फाइल कैसे डाउनलोड करेंगे?
सर फाइल मोबाइल में डाउनलोड कर रहे हैं अभी
सर
और
एक ही बात है ना जी,
लैपटॉप में कन्वर्ट.
एक ही बात है, लैपटॉप से डाउनलोड करें, जहाँ से भी डाउनलोड करें, उसको ओपन करें अपने लैपटॉप पे. ठीक है, दैट्स ऑल आई वांट. आई डोंट वांट कि भाई आप लैपटॉप कनेक्टेड है कि नहीं.
ओके सर, थैंक यू.
हाँ जी.
एक्सक्यूज मी सर.
जी जी.
सर पहले वाला फाइल डाउनलोड को गया हूँ स्टार्टअप को सर.
डाउनलोड का स्टार्टअप से कोई ताल्लुक नहीं है. ठीक है, जब मैंने इधर कह दिया कि ओपन द स्क्रिप्ट, जो चाहे अभी डाउनलोड करके ओपन करें कि पहले से डाउनलोडेड और अब ओपन करें, ये स्टेप हम रोजाना लैब में करते हैं. तो अब आई डोंट नो आप इसके बारे में क्या पूछ रहे हैं. So this is the MATLAB file that you have in front of you. Okay. सबसे पहले we are running this command. Actually, it's a script which will help us simulate the Puma 560 robot. So if you just right click on it and evaluate it, so it will create this object called P560. It's a serial link. It's a 6 degrees of freedom robot. Okay. Once you have done that, all of you should follow me by running each section. If you get stuck somewhere, then just ask right away. Okay. Or joint singularities. So what are singularities? If you remember from last time, singularities, it is a configuration. These are the values of the joint variables, which makes the determinant of the Jacobian 0. So this is what is a singularity? It is a robot configuration. Configuration means it's a set of joint values at which the determinant of Jacobian is 0. So that's the simplest definition if you remember from the theory class. So I'll paste it here. Okay. It's described as a singularity, or singular configuration. Okay. So how we will check that a certain configuration is singular? So you just find the Jacobian at that particular configuration. Let's say we have QR. QR is this in radians. Okay. So it's pi by 2. Second joint is has rotated pi by 2. Third joint has rotated in the clockwise direction by pi by 2. And all other joints are 0. They have not rotated. Okay. Even if you want, you can plot and see this configuration. So it looks like this. This one. This is our Q0. Okay. QR. So I'll take a screenshot of this. So this is our QR. So we want to see whether this QR is singular or not. It's a singularity or not. These are its values. Okay. Okay. Now the command for that is take the robot's name, which you have already created, P560, dot, first of all, find the Jacobian. This 0 mean in base frame, Jacobian relative to everything, the velocities that it will give you, they will be relative to the base frame. Okay. And give it that QR at which you find, you're trying to find the singularity. Okay. So I'll write here, step 1. This is our Q, and plot a given configuration, for example, QR. Okay. Step number 2 is evaluate or compute the Jacobian matrix 8QR. The command for that is P560 dot Jacob 0 and Q. Whatever is Q given to you, you want to find the Jacobian at that. So if you run this, you'll see the Jacobian. It should be a 6 by 6 matrix, and it's given here. Okay. You can also see it from here. It's a 6 by 6 matrix, 6 rows, 6 columns. Okay. So you get this Jacobian. If it is not visible properly like this, then the best way is to copy it like this. Okay, so this is your J Jacobian matrix. This is your Jacobian matrix. Now, we want to see whether this Jacobian is singular matrix or not. If it is, then its inverse will not exist. Okay, and that's why we'll say that that configuration, the given configuration, was a singularity because the Jacobian that we got for that configuration was singular. So next step is check whether the resulting Jacobian matrix is singular or not. So how to do that? For that, the command is just find the determinant of J. Because we know that the inverse of a matrix A can be found as this, that inverse of A, how to write it? Let me see here. The inverse of a matrix, the formula to find the inverse of a matrix is, okay, I can write it just in any format. Okay. Let's write it like this. Inverse of A is determinant of A multiplied by adjoint of A. Okay. 1 over determinant of A. 1 over determinant of A multiplied by. So if this determinant of A is 0, then the inverse will not exist. So we'll say that J is singular. So just find the determinant of J. Okay. J is coming from the previous. First, yeah. So let's call this J. Okay. जो वहाँ से हमारे पास J आया, we stored it in a variable J. And now we take that J matrix and find its determinant. So if you do this now here, so if it gives us 0, okay, then it means the Jacobian matrix was 0. So the determinant that it gives is 0. Okay. If the resulting determinant is 0, J matrix J is singular, and therefore the given configuration QR represents, is a singular configuration. Okay. So now your job is, first robot task is, sorry, this should have been in everything here. It should be in procedure. This is actually a procedure that I'm doing. So, okay. So this is your step number 4, step number 5, step number 6. Okay. Now your task is, the important theory about today's lab, I'll just put it before the procedure. Okay. Now your task is, first task, check whether the following configurations are singular or not. So which configuration? Qn. Okay, so this is our Qn. All right, so this will be this. Let's make it 3.14. Let's make it 0.785. So there are 6 joints, 0.78. Okay, these are in radians. I'll write it in radians. So that is your first task. So please do that and I'll check and then I'll proceed to the next one.